from here, all this, skip it. See, you don't need it. It will take us too long to go around this. So all the way from yeah, skip them. So move from there all the way to where I say recall to merge prices. Okay, so move from here all the way to here. Get to recall. Yeah, get here. And then we'll continue from here. So forget about that all those codes up to here. Are you here?
Yes, please.
Yeah.
Okay, great. So this is what we want to do. You saw that. No, before that, let's do it from here. Okay, so if you look at this carefully, we are loading the same data files, but we are giving them different names: GH1, SA1, EGT1, NIG1, right? Okay, so run them. All things in being equal, these files should load without any issues. Run them for us. Are you there? There shouldn't be any issues at all. Oh, talk to me.
Yeah, we are running.
Is it just the GH1 or the head should follow?
Doesn't matter, but just run them, all those lines, run them one by one, or you can highlight all of them and run up to here, up to where I am, up to where these hash signs are.
Okay, I'm done.
Are you both there?
Yeah.
Great. Okay, so let's run this, type these lines and run dimensions. You want to look at the dimensions of all of them. You should process your data to be like that before you think of comparing them. And that's what I want to show you. This is the last thing we are doing in terms of the data pre-processing. Because if you look at the dimensions here, first of all, the dates. So look at the head for Ghana, for example. Look at it. Hold on, before that, look at the dimensions. Ghana is 2,300 and no 2,900 and whatever it is, 2,939, right? And then
39.
SA is 5,909. Egypt is 3,250, and Nigeria is 4,832. Very different data points. Okay, that's the first thing. The second thing is that if you look at the heads, realize that they start from different dates. So Ghana starts from 2011. I mean, March 2011. SA starts from where? I mean, I think it's upside down anyway. So let me look at the tail for SA. I know where it starts from. starts from 1995. You see, Egypt starts from where? So the tail will tell us where it's starting from. It's starting from 2006. Okay, and then let's see where Nigeria starts from. Okay, so that's so Farouk, can you see that the arrangement of the date doesn't really matter?
Yes.
Nigeria starts from 1999. You can't compare them like that. If you are doing univariate analysis, so you're analyzing each country on its own, then you can do that. But if you are putting them together to compare head to head, then they should have the same data size, length, starting date, and ending date. So it depends on what exactly your analysis is. But so an example is this wavelet that we are talking about. If you are doing wavelets, the data cannot be of different sizes. It should be balanced, head to head, one to one. Okay. Which means we have to cut out the one with a large data, the large size, and bring it to the level of the smaller size. So this is what we want to do. We want to make sure that we have balanced data, balanced. And the function that does that is the merge function. It's a very simple line of code, but it does a lot of work. And you only know the amount of work it does if you are working with, say, if it's a high frequency data. If you are doing high frequency data and you run this line, it can take 15 minutes for it to run, because it's going to do a lot of computation, going through each of the data and comparing the dates to make sure that they are matching. So it will remove all the ones that are not matching and keep the ones that are matching. Okay. So, and I've written here the data should be data frame. So if I go to class, so NIG1, it's a data frame. It doesn't accept STS, it doesn't accept zoo, it has to be a data frame. In other words, it has to be a table. And the data frame is almost always what you load into R at the start. So here you realize that we loaded them, they come as data frame. Okay, so this is what you want to do. Now, look at the dimensions again. It is going to remove the data that the columns, the rows that do not match. If that's the case, you actually want to start with the ones that are long. Because if you start with the smaller one, for example, we start with Ghana, and you add it to Nigeria, it's going to cut it down to the size of Ghana. Are you following?
Yes.
It will cut it down to the size of Ghana. But then you have something like Egypt, which is 3,000. And when you now add it to Ghana, it will not, you will not get the 32,000. So always start with the largest and move down to the smallest. Right? Are we good?
Yes.
Okay. So now this is how it works. I'm taking time to explain this. It's very important. This is how it works. Okay. You can only merge the data two at a time. Note that very carefully. So if you come here, you realize that we have SA, GH1 and SA1, two at a time. Let me clean this. And from what I said, you have from the largest going. So the largest data here is SA, right? SA1. And then the next largest is what? Look at the dimensions. Which one is the next larger?
Nigeria.
Nigeria, so NIG1. Okay, so that's it. Now, one more thing. Look at the head of Nigeria and SA. Let me just put them here. Head of Nigeria. One. Head of SA1. Okay. Look at the two data or the two objects. We have date NIG, date SA. Now, for you to be able to merge, there should be one column which you are going to use as the merging criteria. And that column should be common to the two data. So here, date, you see the date column? How it is written, see there's DAT in lowercase, it should be the same as for SA DAT data column because it's going to use that column to match. Are you following me?
Yes.
Yeah.
If there isn't a common column, it cannot match. So if you later, when you see the merge, the original merge function, you see that you have match by, then you choose. But we don't have to choose because it will pick it automatically. So if you are going to merge any number of data, you should have a common column with the same name. If you don't, it will not work. Okay, so now, when you merge, we want to merge it into one data, one table, and call it PP1, right? PP1. So if you run this line, we now have one table called PP1. So if you, do you see what we have now? Why is it fine? Okay, so you see, so now we don't have SA and Nigeria standing somewhere. We have Nigeria and SA together with dates in the table PP1. Okay, I said we'll merge one after the other, right? Yes, exactly. We have to merge two at a time. So here we merge SA and Nigeria, which is now PP1. So, I mean, let me clarify. You cannot merge, you can only merge two data frames at a time. Two data frames at a time. So, SA1 is one data frame, NIG is one data frame. Now, when we merge, we have one data frame called PP1. Agreed?
Very well.
Yes, now we can add another data frame to PP1. So we have two data frames now. So to do that, we want to say that PP2 is our new data frame. And we want to add EGT1 to the data frame. But before we choose whether to use EGT, we should check the dimensions again and see if that's the best option. So look at the sizes. We merged SA and NIG because they were the larger ones. The next large one is what? The EGT. Agreed?
Yes.
Yes, so we can now add EGT to it. And then, so our new data frame is PP2, which has our three variables. Are we good?
Yeah.
Good.
So did we check whether Egypt has the same column with PP1?
Yes, we did. In fact, that was the reason for letting you run the head every time, or the tail. They have. We know, I know. I just wanted you to show. I wanted to show you. The columns, there should be a common column, date, 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 which is running through. Okay, so here, if you look at this one, for example, realize that we have date, SA, NIG, EGT. And the last one we want to add is Ghana. That's the last one. It's the shortest, right? GHA1. Yes. Now, if you check the head of GHA1, what do we see? It also has dates. So we have a common column. Are we good?
Yes.
So we can merge. So it's now PP2 here. I want to add GH1 to, and you want to name it PP3. Okay. So if you run that one, now we have all our data points. If you remember, some of them started from 1999, others started from 2005, others started from what? Something like that. But now all of them are starting from 2006. Let's look at the table. All of them are starting from 2006 and ending at 2011. We have a perfectly balanced data. And if you are doing a comparative study, this is the final data you are going to use.
So in the nutshell, it downsizes it from the longest to the shortest.
That is, you can say that, but that's not the purpose. The purpose is to match the dates. So if it is matching and one is shorter, it will automatically downsize the larger one.
So this exercise is practically suitable for the multivariate.
So in fact, it's also suitable for the bivariate. Because if you are comparing Nigeria and Ghana, you have to make sure that Nigeria and Ghana are balanced. But remember, you are likely to also compare Ghana and Egypt. So they also should be balanced. And then Ghana and maybe SA, they should also be balanced. So you can keep the balanced data 2 by 2 if you are doing bivariate, or you balance all of them, because at the end of the day, you are going to pair each against the other. Do you get the point?
Makes sense, yes.
Yeah. So it is better to balance all of them than to balance them 2 by 2. In fact, it will not work, because if you are comparing, you are going to compare all of them, then balance them at once. Otherwise, if you are sure you compare Ghana and Nigeria, but you will not compare Ghana and Egypt, then you can just balance Ghana and Nigeria, you leave them there. Then go and balance Egypt and say South Africa, you leave them there, because you just do bivariate for the two separately. If you are going to do bivariate across, they should be balanced. Great. So this is your data. And we don't want to lose it, so we want to save it. You don't want to lose it at all. So this is what I want to do. Look at this function very carefully. You always come back to it. So look, write.csv. It means that you are going to save your data into CSV. And what is our data? Our final data that we want is the PP3. Is it?
Yes.
Great. Now, so this is the PP3, this is what we have. We have it here. It is our object that we want to save. We want to give it this name. So whatever name you want, that one is up to you. So file equal to the name of the, how you want to save your data. And don't forget the extension .csv. So I have a question for you. When you run this line, where do you think your output will go to? Your file, African stocks prices, where do you think it will go? Where do you think you will find it? Where do you think you will find it? Where? Oh, I'm listening. To run this, if you're able to do it successfully, you should go into your working directory straight, and you can go there and open it. The next time you are working, that's what you are going to use, because that's the data you have pre-processed to work with. So you go to your working directory, you should find it there. Here. And I want to do one more thing before I let you run and I will follow. Okay, this is it. So this column, can you see my screen?
Yeah.
Can you see my screen?
Yes.
Yeah, this very first column is useless. I don't need it. This column here. I don't need it. So I need to remove it. And this is what removes that. So I'll do the same thing, but I'll do this. See the argument I've added, row.names equal to false. That will remove that column. And I want to save it as African stocks prices 1. So I have those two files. See that this one doesn't have that column. I don't need it for anything. Great. Okay, so now over to you. If you want to share your screen, let's go through to get to this stage. And that will be the end of our introductory, our baby walk. Okay, so from the merge, who is up? And after that, I'll give you